Hey class, today we're going to talk about modeling with quadratic functions. So we're going to model data with quadratic functions. In example 1, with writing an equation of a parabola, it says a parabola contains the points 0, 0, which is the origin, -1, -2, and 1, 6. What is the equation of this parabola in standard form? So what we need to do here is first go back and talk about standard form. Remember, standard form is y equals ax squared plus bx plus c. Okay? Now that we have that information, what we're going to do is we're going to substitute each of these ordered pairs into the standard form. Now, 0, 0 is going to be fairly easy, right? Because 0 is x and y is also 0. So we'll have 0 equals a times 0 squared plus b times 0 plus c. That'll basically tell us that 0 equals c. So that's great. At least now we know what one of our values is. Next we would do -1, -2. So I would do -2 equals a times -1 squared plus b times -1 plus c. And that will give me -2 equal to -1 squared is 1, so that's a, minus b plus c. And I have that as an equation. And finally I plug in the last one, and I get 6 equal to a times 1 squared plus b times 1 plus c. That will give us 6 is equal to a plus b plus c. So at this point we have, technically we have two systems, but of those two systems we happen to know that c is 0, so that's like getting rid of these c's. So based off of that information I have, if I put it in the right order, because this is kind of backwards, I basically have a minus b equal to -2 and a plus b equal to 6. This should remind you of a system, okay? And we're going to use elimination. So we can eliminate the b. So a plus a is 2a equal to 4. So if I divide by 2, a will equal 2. So now we have a and we have c. So finally, to get b, remember all we have to do is substitute back into one of the equations. And so I'm going to choose to substitute into this equation here. So that'll give me 2 plus b equals 6, so b must equal 4. So as our final answer, we need to go ahead and remember to write this back in standard form. So y equals ax squared, so that's 2x squared, plus bx, which is plus 4x, and then plus c, which c is just 0, so we'll leave it off. And that's our final answer. Let's go ahead and do the try associated with this problem. So again, we're given 3 points, and we're asked to write the equation of that line in standard form. And remember, standard form is y equals ax squared plus bx plus c. Okay? So when we start 0, 0, remember that's basically just going to tell us that c is going to equal 0. Okay, so we don't need to do anything with that information. But let's keep going. If I substitute in 1, -2, I'll have -2 equal to a times 1 squared plus b times 1 plus c. That's really -2 equal to a plus b plus c. The next one, when we substitute in -1, -4, we'll have -4 equal to a times -1 squared plus b times -1 plus c. That'll again give us a minus b and then plus c. All right, again, since c is equal to 0, that's like getting rid of the c's here. And so if I flip this back around, the first one should be a plus b equals -2, and then a minus b equals -4. B's are gone, a plus a is 2a, and I get -6. If I divide by 2, a will equal -3. So I've got two answers. Finally, if I substitute that information into, let's choose the top one. So it's negative 3 plus b equals negative 2. If I add 3 to both sides, b will equal 1. So as our final answer, A, B, and C, for our standard form, we should have y equals negative 3x squared plus x. And we're done. In example 2, it says a player throws a basketball toward the hoop. The basketball follows a parabolic path through the points shown, which is on the next screen, by the way. It says if the center of the hoop is at 12:10, will the ball pass through the hoop? So let's take a look at that picture to see what's happening here. All right, so we see the 3 ordered pairs, okay? So we're going to substitute that information just like we did in the last problem to create a system. So let's do that for the first ordered pair, 2, 10, okay? So that would be 10, I should probably write a little higher. So 10 equals a times 2 squared plus bx, so that's b times 2 plus c. That will give us 10 equal to 2 squared is 4, so that's 4a plus 2b plus c. The next one, 12 equals a times 4 squared plus b times 4 plus c. That'll give us 12 equal to 16a plus 4b plus c. Last, we have 10, 12. So we have 12 equal to a times 10 squared plus b times 10 plus c. That'll be 12 equal to 100a plus 10b plus c. Okay, now if I rewrote all those, which I can go ahead and rewrite it down here at the very bottom. Actually, no, I won't rewrite them. Just realize that all of them are basically a matrix, right? So this is a 3 by 4, right? So we would create a matrix to make this easier on ourselves. So if I set this up as a matrix, we should still remember this, but this would be 4, 2, 1, 10. Maybe I should move this over just a little bit. Okay, so 4, 2, 1, 10. And then 16, 4, 1, 12. And then finally, this last one, oh, and I forgot the C. The last one should be 100, 10, 1, and 12. And so if we type that into our calculator, our A value will equal negative 0.125. Our B value will equal 1.75. And our C value will equal 7. Now, what does that mean? Well, let's see if we can finish our work on the next. Let's go ahead and do that. All right, so if we finish up our work from the previous page again, A equals negative 0.125, B equals 1.75, and C equals 7. So if I make an equation of that, that would be y equals negative 0.125 x squared plus 1.75 x plus 7. Now remember, the original question said, will the ball pass through the hoop at 12:10? So to see, in other words, it's asking, is 12:10 a solution of this graph here? Well, to see if it's a solution, we would have to substitute in the ordered pair 12:10. So let's do that. We would have 10 equal to negative 0.125 times 12 squared plus 1.75 times 12 plus 7. Okay? If we went through all of that, what you would get is 10 is equal to 10, which means that yes, it is a solution. So yes, the ball will pass through the hoop at 12:10. And that's it. All right, guys, finally, in example 3, we're using quadratic regression. It says a table shows the meteorologist's predicted temperatures for an October day in Sacramento, California. It says, what is a quadratic model for this data? Okay, so let's go ahead and take a look at that data. Okay, so we see our times, okay? So what's really nice about this, guys, is that we've actually already done linear regression, right? When we were dealing with statistics, kind of early on when we were dealing with scatter plots and things like that. So all we're going to do is type in this information exactly as we see it into the list portion of our calculator. And then when we're done, remember you press stat and you'll go down to go over to calc and then go down to quad reg, which is quadratic regression. And at that point, we'll see the general setup of ax squared plus bx plus c. And then we'll see that a is going to be equal to negative 0.469. B is going to be equal to 14.716. And C is going to be equal to negative 36.121. So guess what? We have everything we need to be able to write our equation. So y would equal negative 0.469x squared plus 14.716x minus 36.121. Okay? And actually, that is it for this problem. All we needed to do is create the, oh no, I'm sorry, there's one more part. It then said to use your model to predict the high temperature for the day. So what time does the high temperature occur? So really, okay, so at this point, what we can do is go to our graph and actually graph these points, okay? And then we could do the maximum feature, which is found, and I'll show you guys how to do that in class. And then you would notice that your maximum, so if it's your maximum, that would be the high of the day, right? Because it's the vertex. And so the maximum temperature, which is your Y value, would be about 79.4 degrees at 3:42 p.m. Okay? And that is it for this example. Remember, guys, if you need any help or you need to come in for tutoring, just come in and we can work through our problems.